determine the service load for a small gas or electric restaurant, begin by calculating the base load. This involves considering the lighting load, which is typically 3 watts per square foot of floor area. Then, determine the outlet load, usually around 1 watt per square foot of floor area. The HVAC load should be calculated based on its capacity in British thermal units, or BTUs, and its efficiency ratings such as Seasonal Energy Efficiency Ratio, or SEER, or Annual Fuel Utilization Efficiency, or FUE. Include any other fixed loads, such as refrigeration equipment or security systems. Next, add the equipment loads. For the hot water booster operating at 208 volts, 3-phase, and 48 amps, the calculation is 208 volts times 48 amps times the square root of 3, which is approximately 1.732, which equals approximately 17,306 volt amps per phase, times 3 phases, equaling approximately 51,918 volt amps, or 51.918 kilovolt amps, which is then converted to kilowatts, assuming unity power factor, which equals 51.918 kilowatts. For the dishwasher operating at 120 volts single phase and 16 amps, the calculation is 120 volts times 16 amps, which equals 1920 volt amps, or 1.92 kilowatts, assuming unity power factor. Calculate the total load by adding the base load to the equipment loads. Then determine the demand factor. For commercial buildings, a demand factor of 0.75 is commonly used, meaning that only 75% of the total load is expected to be used simultaneously. Calculate the service capacity by multiplying the total load by the demand factor. The formula for service capacity is the sum of the base load plus equipment loads multiplied by the demand factor. Here is an example calculation. Suppose the building has 2,000 square feet of floor area. The base load would be 2,000 square feet times 3 watts per square foot plus 2,000 square feet times 1 watt per square foot, which equals 6,000 watts plus 2,000 watts, which equals 8,000 watts, or 8 kilowatts. The equipment loads consist of the hot water booster at 51.918 kilowatts, plus the dishwasher at 1.92 kilowatts, totaling 53.838 kilowatts. The total load is the base load of 8 kilowatts, plus the equipment loads of 53.838 kilowatts, totaling 61.838 kilowatts. Using a demand factor of 0.75, the service capacity is 61.838 kilowatts times 0.75, which equals 46,3785 kilowatts. It's important to note that this is a simplified calculation and may not account for all aspects of the electrical system. Consulting with a qualified electrician for a more accurate service calculation is recommended. For reference, the National Electrical Code, or NEC, is a valuable resource. Another helpful book is the Electrical Estimating Manual Residential, Commercial, and Industrial by Ray C. Miller. The NEC provides guidelines and regulations for electrical installations, while the Estimating Manual offers insights into cost estimation for various electrical projects. This step-by-step approach aids in determining the service load calculation for a restaurant by considering the different types of electrical loads in order to arrive at a final value. Calculating total load from lighting, outlets, and HVAC is essential for determining the necessary capacity. Including the hot water booster and dishwasher load is an important step to obtain a proper estimation. Applying a demand factor allows for the consideration that not all equipment is running at the same time. All of these combined can help provide a proper estimation. However, it is still important to consult with an expert who is a qualified electrician for a more accurate service calculation. An electrician will be able to consider many different elements such as local codes and rules, as well as specific installation details and equipment information.